Okay, next example is asking you is this a trapezoid? Okay, so we don't necessarily need to do distance formula on this one. On trapezoids, we know that the top is the ones that I'm highlighting. Those two are going to be parallel, okay? So that one and that one, those two are going to be parallel. Since they're going to be parallel, technically, to figure out the formula we're going to use is the slope formula. In fact, it even says use slope formula to determine if only one pair of opposite sides are parallel. So if we have one set of opposite sides being parallel, then we know we have a trapezoid. Okay. So one of the things what we can compare is we want to compare all the sides. Okay, A, B, C, and D. We can do the slope of AB first, then BC, then CD, then AD, and then we're going to come back and check to see if we have a set of parallel lines, okay? So I want you to I'm going to pause it and then I'm going to come back with the answer. Okay, so in this problem, you'll notice I have all the slopes. In fact, I'll do them in blue. Okay, do we have any of these pairs of opposite sides that are considered parallel? Okay, well, we have BC and AD are both 1/2. And BC is this bottom portion, and AD is this top portion. Okay, so those are parallel. Since they are parallel, then yes, this is a trapezoid. Guess you don't have to put trapezoid. So yeah, yes, based off what we did up above it. Okay. Okay, so now the next thing is asking you is this going to be a kite? And remember, for it to be a kite, this segment is also going to be the same as this segment, or congruent. This segment is going to be congruent to this segment. Okay, so basically we have to do, things being distance, things being the length of something, so we need to do the distance formula. Okay, so the distance formula is x2 minus x1 squared plus y2 minus y1 squared, and then do the square root of all that, okay? I'm going to do it and come back. Okay, so I did this as formula for all of these points, or for all these lengths, okay? And you'll notice that I have the 5 as JK and also MJ, so JK and MJ are both 5, okay? And then we also look at the square root 10s with KL and LM. Okay, so is this a kite? Yes, it is. Okay, so yes, this is a kite. So this would be a yes on that. Okay? All right, so let's take a look at another one. It says, is the quadrilateral a kite, a trapezoid, or neither? Okay, so if it's a kite, distance formula. Okay, if it's a trapezoid, do slope formula. So you may have to do both. Okay, so you may have to do both on this particular problem. So do both of those. Pause it, try it, see what you can do. I'll come back with the answers laid out for you. All right, so I squeezed all this in here. So with xy, here's your distance, here's your slope. xw, here's your distance, here's your slope. yz, wz, here's your distance, here's your slope. And yz, here's your distance, here's your slope. So in order for it to be a kite, the distance formula, we have to see if two sides match and a different two sides match. Well, if we look at all of these distance formulas, or all these lengths, none of them are actually the same. So that's definitely not going to be a kite. Okay, so not a kite. So the next one is a trapezoid to see if we have opposite sides being parallel. Okay, well, we look for our slopes and try to find two matching ones. Well, we don't have a pair that's matching either. So this is also not a trapezoid. So this is neither in this situation. I know what you're thinking. It's a lot of work just for being neither. You know, you got to put the work in. Okay? I've said it before, I'll say it again. I'm sure you've heard it before. All right, so this one's saying that Dylan is going to be put up a yard, is going to enclose his yard for some chickens. So it's basically asking you now, it's like he has 30 feet of fencing. Is that going to be enough to enclose the yard? Okay, well, what it's basically asking is, will this, if 30 feet, will that be enough for this? Okay, well, the only way we can really figure that out is we got to know what the perimeter is. Okay, so we need to find the perimeter of this, which means you would add up all of the sides. Okay, well, if we, in order to add up the sides, we need to know what the sides are. In order to figure out what those sides are, we have to find the length of them. In order to find the length of them, you have to find the distance, which then you'd use the distance formula. So, in this particular problem, be distance formula. So, we'll pause it and come back to the answer. All right, so now let's take our lengths, which is 10, square root of 80, and 10, and add them all together. Okay, and when you do that, even with your handy-dandy calculator, what you'll end up with is approximately 28.9 feet. Okay, so the question is, he has 30 feet of fencing. Is that enough to enclose his yard? He has 30, 28.9 is how much is needed. So this will be a giant yes. Yes, this will be enough for Dylan here. Okay, this is a little bit tricky-ish because it's asking for, so basically you need to find the area. Okay, well, for the previous problem, remember to find the area, it is the area of a triangle is 1/2 base times height. Okay, well, we have the base. Okay, the base from earlier was, I believe it was the AC. So AC we saw was square root of 80. Okay, so our base is going to be the square root of 80. Now the height is actually this little dotted line that I'm drawing. Okay, or this green one. Okay, that's the height. Okay, well, to figure that out, we really don't know. So what we need to do is we need to find the center. Okay, we got to find the middle. Once we find the middle, the coordinates. Once we have the coordinates up here. Then we can find the distance formula with that. So the first thing we need to do is find the midpoint. Second, distance. Okay, so let's do both of those and we'll come back. I'll come back to the answer. But you do it first and then come back and pause it and stuff. Then I'll come back with the answer. All right, so first I found the midpoint of AC to find the middle here. I did its coordinates, which I got the coordinates from the previous diagram. So I did end up getting 6, 4. That 6, 4 is right here. So I have coordinates here. I have coordinates up here with my B. Now I can plug that into the distance formula and end up with the square root of 80. Okay. So now going back to our area, 1/2 times the base, which the base is this portion here. So that's the square root of 80 times our height, which is this portion here. Also the square root of 80. By the time you multiply all of that together, you end up getting 40. Okay, so then it's asking you, how many chickens can we use? Well, if you look up here, it says you need at least 8 square feet of space for one chicken. Okay, so then we take this 40 divide it by 8, and we end up with 5. Okay, so we can get 5 chickens in that space that Dylan has drew up for his from his yard. Okay, so yes, again, a lot of work. So be it. It's all right. You'll live. And ready for the error analysis portion of this. Okay, so with the error analysis here, it says Chin asked to describe two methods to find BC. He says, and it says the only possible way to use this distance formula because you know the endpoints of BC. Okay, that is one of the ways. That's true, but that is not the only way. Okay, this is a right triangle. Okay, you have a right triangle, which means you have a right triangle. A right triangle, you have that box there. So if you have a right triangle, you can always use Pythagorean theorem. Okay, if you have Pythagorean theorem, the bottom part is 3, the height is 4, and you can do that just by counting. And then you can use Pythagorean theorem to figure what that is. Okay, 3 squared plus 4 squared equals c squared. This is our c. So you end up with 9 plus 16 is equal to c squared. You end up with 25 is equal to c squared. Take the square root, and c equals 5. But that's also a Pythagorean triple. I don't know if you've done Pythagorean triples or not, but in this, actually, we'll do Pythagorean triples. I think on the next unit that we decide to do, or next unit that we're going to do. Okay, so this finishes up, and good luck on your assignment.